Hello and welcome to today's lesson on polyhedra and other solids. So what that basically means is we're talking about 3D shapes such as prisms, pyramids, cones, cylinders, spheres, and how to calculate their surface area and their volume. So this is going to cover topics in the standard 4.1 in geometry, and then also that study island lesson called Polyhedra and Other Solids. So as you're watching this video, I highly encourage you to take notes, and if I go too fast, you can always pause or rewind. And then once you see a couple examples, go ahead and pause at the beginning of an example, work it out, see how you do, and then watch to check yourself. So I am so glad that you made time to watch this video today, and let's go ahead and look at some notes. First, we're going to know the parts of a polyhedron or a 3D shape. So the flat sides are called faces. The corners are called vertices. And then the seams where they meet, these are called edges. And then we have different types of three-dimensional shapes or polyhedron. The first type is a pyramid, and a pyramid can have different types of bases. So this one has a triangle base, a square base, a pentagon base, and a hexagon base. And depending on what shape their bases is, that's going to depend on what type of pyramid it is, as you see in these names. And so then a pyramid, you have your base, and then from each side of that base, a triangle comes up and meets at a point. So a triangle base has 3 sides, so it's going to have 3 triangles coming up. A pentagon base has 5 sides, so it has 5 triangles coming up and meeting at a point. And that is what a pyramid is. And so you're going to, in order to calculate the surface area of a pyramid, is you're going to take the area of the base, that's what the big B stands for area of the base. And then that's going to be, you're going to add that to 1/2 of the perimeter, that's what the capital P is, times the slant length, or the slant height, which is the height of the outside triangles. And then to calculate the volume, that's going to be 1/3 times the area of the base times the height. And so the height is coming down from the point to the base at a 90-degree angle. Another type of polyhedron or 3D shape is a prism. And here are all different types of prisms. So if you notice here, the prism, you have 2 identical shapes at the top and the bottom, or the left to the right, and then rectangles coming up from the sides to connect those 2 identical shapes. So here I have 2 triangles and then 3 rectangles. So here I have 2 squares and 3 rectangles, which are also squares, so that's the cube. Here I have 2 rectangles, and then the 4 rectangles coming off of them. Here I have 2 pentagons and then 5 rectangles to connect them. And here I have 2 hexagons and 6 rectangles to connect those hexagons. That's what a prism is. So pyramid meets at a point. Hexagon, or a prism, has the 2 shapes that are identical at either end. And to find the surface area of a prism, you're going to take 2 times the area of the base plus the perimeter times the height. And there it lists out what those letters stand for. And then the volume is the area of the base times the height of the prism. Our next polyhedron is a cylinder. And a cylinder, that's like your Pringles can or a soda can, pop can. And we are going to want to calculate the volume and the surface area of those also. So the surface area formula is 2 times pi, which stands for 3.14, times the radius squared plus 2 times pi times the radius times the height. And so here, the radius is from the center of the circle to the edge. You have a circle at the top and the bottom. And the height is the distance between those two circles. And then our volume formula is volume equals pi times radius squared times the height. Then we also have a cone. So like your party hat, your ice cream cone, the ones that meet at a point, those are all different types of cones. And we're going to want to calculate the volume and surface area of those also. So the volume here is 1/3 times pi times the radius squared times the height. So here the radius is that bottom circle where you have, it goes from the center to the edge. And then the height is the center of the circle up to the point. And then our surface area formula is equal to pi times the radius times s, where s is this slant height, which is sometimes labeled as L for slant length, depending on which formula you're using. And you add that to pi times the radius squared. So you have that same radius again. And so we have all these different polyhedra, and we're going to be using those to calculate the volume and the slant length. Remember, volume is how much an object can hold. So a volume of a pop bottle might be 2 liters. That's how much it can hold. Whereas the surface area is if you were to cut this and lay it flat, that's how much area its surface takes up. Then our last polyhedron is a sphere, which is a ball. And the area, to calculate the surface area of that, you take 4 times pi times the radius squared, where the radius is the center of the sphere to the edge. And the volume is equal to 4/3 times pi times the radius cubed. Okay, so taking all that knowledge from our notes, let's go ahead and look at a few examples. If the base of a pyramid has 6 sides, how many faces does the pyramid have? So that means that we have a hexagon for the base of our pyramid, and then we have the 6 triangles coming up. So that means I have the face, remember, is the flat side. So I have the bottom and then the 6 triangles. So that's going to be A7. And so here, let's go ahead. You don't get this picture on the EOI or in Study Island, but just to help you visualize where I'm getting 7 as you're getting used to these is here's my one base. And then my 1, 2, 3, 4, 5, 6 triangles coming up. Number 2 says, if the base of a prism has 8 sides, how many edges does the prism have? Now remember, prisms, you have 2 shapes opposite each other that are the same shape. So you have, the base is an octagon, so that means I'm going to have 2 octagons opposite each other, and then the rectangles connecting them. So each octagon is going to give me 8 edges. So that's going to give me 16. And then the rectangles that are connecting them, that's going to give me 8 more for their seams where they touch for a total of 24. So my answer here is B. Now, you have to visualize that in your head for the EOI. However, you could sketch something out like this if that helps you, and then actually count up the edges. And so if you count up all the edges, and remember the edges are the seams, you would count 24 here. And some of the questions do give you pictures. And so here, this one, it gave us a picture of this pentagonal pyramid, and it wants to know how many vertices does it have. Remember, vertices are the corners. So this pentagon is going to have 1, 2, 3, 4, 5 corners, or 5 vertices, and then the one at the top of the pyramid where all the triangles meet makes 6. So my answer here is A. This question reads, Jennifer bought a package of lotions for her birthday. The package is a cylinder shaped with a height of 9 inches and a diameter of 3 inches. If Jennifer wants to wrap the package with gift wrap, about how much gift wrap will she need, not counting overlap? Use pi equals 3.14. So she has a cylinder and she wants to cover the entire surface in gift paper. So that means she's going to need to figure out the surface area to see how much gift wrap she needs. So our surface area formula for a cylinder is 2 times pi times the radius squared plus 2 times pi times the radius times h. So then I'm just going to fill in what I know. It looks like I'm going to need to know what the radius is and what the height is. So up here in my problem, it tells me it's a height of 9 and a diameter of 3. Remember, it takes 2 radiuses to make a diameter. So my radius is going to be 1.5. So I'm going to go ahead and fill that in. So I'm going to take 2 times 3.14 times 1.5 squared plus 2 times 3.14 times my radius, which is 1.5, times my height, which is 9. And so you can just, if you have a smart calculator, you can just type this all in and get your answer. Or you can follow order of operations, in which you would want to do this exponent first, and then you would do the multiplication, and then you would do the addition. Either way, you should get an answer of 98.91, which the unit here is inches squared, because you're working with area, so your answer is A. So this question here says, if the radius of the sphere above is 3 inches, what is the approximate volume of the sphere? Well, I need to know that the volume formula of this sphere is volume equals 4/3 times pi times radius cubed. And here it tells me the radius is 3. And it says approximate, so that's another clue that I'm going to use 3.14 for pi. The other clue is that there's no pi symbol in my answer. So I'm just going to write 3.14 for pi, and then my radius is 3, so I'm going to cube that. And so then you just follow order of operations or put this all correctly into your calculator. If you're following order of operations, you're going to take 3 cubed first, which is 3 times 3 is 9 times 27. So this becomes 27. And then you still have these 3 numbers all being multiplied now. And so then you multiply those 3 numbers and you get an answer of 113.10. And the units here is volume, so it's inches cubed, and that's letter B. Right. This question says, Hope is a cake artist. She is building a cake in the shape of a holiday tree for an upcoming holiday party. The cake will have a radius of 12 inches, a height of 16 inches, and the side will measure 20 inches. She wants to cover the cake in green frosting. A sketch of the shape of the cake is below. How much green frosting will she need to cover the cake at minimum? So she's covering the surface of the cake. So that means we're going to be calculating surface area. So the surface area formula for a cone is equal to pi times the radius times the slant height plus pi times the radius squared. And so here they tell us the radius is equal to 12. Here they tell us that our height is 16. And then they tell us also that the side height is 20 inches. So then I'm just going to fill in the information that I need into my formula. The problem tells me to use 3.14 for pi. And I'm going to take that times my radius number, which is 12, times my slant height, which is 20, plus pi, which is, I'm using 3.14, times my radius number, which is 12, squared. And so when I go ahead and work that out, I get an answer of 1,205.76, and I'm working with area, so my units is inches squared. So my answer is D. This question here tells me that the length is 18 millimeters, the width is 6 millimeters, and the height is 24 millimeters. It wants to know, what is the surface area of this prism? So the first thing I'm going to need to know is my surface area formula for a prism, which is 2 times the area of the base plus the perimeter times the height. So here, this is equal to 2. My base is going to be this rectangle here. So my width I know is 6 and my length is 18. To find the area of that rectangle, I take 6 times 18, which is 108. And then I'm going to add that to the perimeter of the base. So now I have another 6 and another 18. So I add 6 plus 6 plus 18 plus 18, and that's 48. And then the height of it all is 24. So that's times 24. So then I go ahead and I do the multiplication first. 2 times 108 is 216. And I add that to 1,152. And then I add those two numbers together to get 1,368. I'm talking about area, so my units is millimeters squared. And that makes my answer B. Alright, so here they tell me the lengths of the different edges, and it wants to know what is the volume of the prism. So in 11, I'm going to need to know my volume formula for a prism, which is the area of the base times height. So here, my base is this triangle. And so the area formula for a triangle is 1/2 base times height. And so I'm going to have 1/2 times the base, which they tell us in the problem is 2, times the height of the triangle, which is going to be h1, which is 5. So I multiply those numbers. 1/2 times 2 is 1. 1 times 5 is 5. So the area of the triangle is 5. So now I can go back over here to my volume formula and put in 5 for the area of the base times the height of the prism. So the height of the prism is the distance between the two triangles, which is h2, which is 15. And then 5 times 15 is going to be 75, and my units is centimeters cubed because my answer is C. Thank you for joining us today, and I hope you learned something new.